One day we will journey to the Red Planet and perhaps settle there. But what great civilizations and cities will emerge on the Red Sands? The earliest description of a city of Mars I know of are the cities of helium at the end of Edgar Rice Burroughs' classic novel A Princess of Mars, in his Barsoom series featuring John Carter. The name itself evokes a high, light, and lofty image, and what little description we get of the city seems to confirm that. The nation of Helium is home to roughly 10 million Martians. It has two primary cities, Greater and Lesser Helium, 75 miles apart, and dominated by an enormous mile-high tower at their center. Travel between them is done by airship or monorail. We also see the city of Zodanga, which in the books is an enormous city with an equally enormous wall, 75 feet high and 50 thick, though the 2012 film John Carter instead shows us a mobile city that's one part fortress and one part factory and refinery, and we discussed it and similar options in last year's episode on mobile cities. The Barsoom series began in 1912 and Burroughs kept writing it all the way up to the beginning of World War II in his late 60s, and was living in Hawaii at the time of Pearl Harbor and became a war correspondent. Needless to say, the science on Mars was pretty limited at the time, so much of what he describes won't apply today as we dip into how, when, and why we might build cities there ourselves. But his work has massively impacted much of the literature on Mars. Probably the next best-known writer on the Red Planet is Kim Stanley Robinson, whose Mars trilogy names its first city Barsoom, and was written in the 1990s and shows its science better. Mars is a fascinating place and shows up in a lot of works and settings. Ray Bradbury's Martian Chronicles, Andy Weir's The Martian, the Martian Mechanicum of Warhammer 40,000, Robert Heinlein's Red Planet, and Stranger in a Strangeland being just a few. It's also the home of the invaders from H.G. Wells' War of the Worlds, beginning a tradition of the Red Planet being home to warlike people, inspired by it being named for the god of war. It is also the basis for Frank Herbert's Dune, the desert world of Arrakis, and shows up in the story Do Androids Dream of Electric Sheep by Philip K. Dick, the basis for the movie Blade Runner, which is in a tie with Dune for my favorite film. The Red Planet inspires us, and no doubt we will travel there one day, and hopefully sooner than later, but it isn't often explained why we would seek to settle Mars and what would bring about cities there, rather than a handful of isolated outposts or homesteads. The definition of a city is rather variable, but my own state of Ohio defines it as having more than 5,000 people, and below that we call it a village. This is hardly universal, but is a fairly common definition and fairly middle of the road. For today, we'll be asking ourselves how you might go about getting to the point where you had more than one city of at least 5,000 people on the Red Planet. One of our problems with Mars is that while there's plenty of reason to go there for some science, there's not a lot of economic reasons to go. Now, to be fair, conducting science itself is a pretty big chunk of our modern economy. The world spends more on it every year than the entire economic output of all but the biggest G7 countries' combined economies. But that's on all science, not the presumably smaller if novel area of Martian geology, hydrology, and other areas of off-planet interest. It's often suggested as a manufacturing hub, an industrial planet or forge world. It has tons of resources on it, just after Earth and Venus in total rocky planet mass and metals, but it is at the bottom of a gravity well, and there are a lot of asteroids out there with plenty of metal, including the two Martian moons of Phobos and Deimos that we discussed settling some months back, and which are probably captured asteroids themselves. Its gravity well is also much lower than Earth and Venus, making transport off-planet significantly easier. Settlement for this reason is almost inevitable, as while the asteroids are handy, Mars has more mass than all of them combined, and indeed has a similar total mass to all of the moons in the solar system combined, including the two biggest, Ganymede and Titan, which each have between a quarter and a fifth of the mass Mars does, and likely much less metals, though more volatiles. Waiting on us to divest all the asteroids of all the resources would likely be a very long process, thousands of years I would think. That isn't a long timetable compared to what's needed to terraform Mars, But we always like to imagine cities there, and a planet nation of Mars sometime in the next few centuries, and that's probably less likely. There's a trend for folks discussing space to either be overly enthusiastic and optimistic about the space development timeline, or to be so pessimistic as to never think it will ever happen. I do not view myself as somewhere in the middle. I'm very optimistic about space colonization. I just expect it to be a long process. Just as an example, the city of St. Augustine in Florida is usually considered the oldest city established by European explorers, founded in 1565, some 73 years after 1492 when Columbus sailed the ocean blue, and a lot longer since Leif Erikson did, or since the first folks crossed the Siberian land bridge, at least 15,000 years ago, and maybe even twice as long before that. But even just using the Spanish example, St. Augustine took a whole lifetime after Columbus to come into existence, and while it was the center of Spanish Florida from the outset, its capital for 2 centuries, and the alternating capital along with Pensacola when the US absorbed Florida in 1821, 329 years after Columbus, it didn't actually reach a population of 5,000 until the early 1900s, about the time the first John Carter novel was published. It's not really exceptional in that regard, and even New York City, which has been the most populated city in the United States in every census since the country started them, only had 33,000 people in it by 1790, displacing Philadelphia, which was the most populous in 1776, both of which served as the fledgling nation's capital pre-DC. Nor is that limited to the colonial Americas. Even the great cities that have been around since antiquity didn't just magically arise one day, and often only did so because they occupied a vital spot for trade or agriculture that encouraged those folks to settle in and build permanent and often fortified homes. We need to appreciate those timescales then when talking about long-term settlement of Mars, but what advantage it does have is that while we would expect some early spaceport of Mars to become a funnel for immigrants, we wouldn't necessarily expect settlers to the Red Planet to leave that spaceport, like some equivalent to Ellis Island. There is no vast sprawling wilderness to carve new farms into. You're building mining sites for resource extraction, and if you're building farms, it's under domes with no native soil, but rather with hydroponics or soil being produced by extensive processing and culturing of the local regolith, where basically every place is more or less the same. Generally, early settlers arriving at ports didn't linger long before going out to claim their farmstead, but that may not apply to Mars. And of course, plenty of folks arriving in New York City did stay there. So you might see settlers just building a dome attached right to the spaceport, and someone attaching right next to their dome in some sprawling dome approach. We had a detailed discussion of domes in our episode The Domes of Mars, and if you're curious, the title of that episode and today's episode are both hat tips to the Barsoom novels A Princess of Mars, The Gods of Mars, The Warlord of Mars, and all the other article noun of Mars books. We were disappointed to learn how dead Mars was after we got better data on it, compared to the vibrant, if often rather desolate portrayals we saw in the Barsoom series or C.S. Lewis's Out of the Silent Planet. But newer data showed us a little more alive in geological and hydrological respects than we had feared. There may even be recent, if minimal, volcanic activity. At the very least, you had some very large volcanoes there. My friend Pascal Lee discovered one there last year that's bigger than my entire state of Ohio. And the famous Olympus Mons, the tallest known mountain in the solar system, is around the size of Poland and is thought to have erupted as recently as 25 million years ago. We often contemplate settlement there as a nice launch ramp for a mass driver into space to help fight that gravity well, and while 2.5 times taller than Mount Everest, Olympus Mons is not a sharp rise. It would be a fairly easy ascent, especially in that low gravity, except that walking a spacesuit is never easy. It should be possible to build a vacuum train or near vacuum train up the side of that to launch, and likely from a tower built even higher. The low gravity on Mars means its atmospheric density drops off slower than on Earth, and the low pressure and gravity also make building taller easier, so you might extend that ramp past the peak's height so as to allow more runway and lower pressure when your spaceship exited the tunnel. But since the orbital velocity of Mars is only about 3.5 kilometers per second, You might skip on any effort to evacuate your launch ramp and just have a bare maglev rail powered by a nuclear reactor that got the ship up to the highest speed it could, and then if necessary, it could burn some onboard fuel to make up the rest of that. A ship leaving for low orbit on Earth, even removing atmospheric drag, needs about a 7-to-1 ratio of fuel to payload in the most optimized case. In that same optimized case, it's a bit more fuel than payload to get to Martian orbit from the surface. And if you had that ship launching up a ramp to say 2,500 meters per second, which is pretty conservative, it could get away with just having about a quarter of its mass as fuel, not much worse than with cars or even planes. And we can make fuel there. Indeed, a fuel production site is another logical location for a spaceport on Mars, and thus another logical place for a city to arise. I should note that we might have 5 or 6 cities arise on Mars with the same purpose in mind, simply because it's not very likely any country would get to claim all of Mars for itself, and entirely likely they'd have rival efforts at work. These need not necessarily be in any way hostile either. We have cooperative but rival national bases on Antarctica, for instance, and a pretty long track record of efforts in space being similarly cordial if not always warm. But even countries that have long track records of friendship might want to do their own thing, and Mars has a lot of room for folks, so there's no need to step on toes. And fuel is a vital resource you probably want to be able to make yourself if you plan on anything other than a minor outpost. So some country might use a NASA or ESA operated spaceport to bring in their initial cargo and crew, but want to get their own fuel production up as quickly as they would want to get their own food production running. Both might benefit from being near the same spots, ones with easy access to water, and old volcanoes on the red planet are a good place to go, and they may still be slightly active, but they'd be pretty safe to build by. Even the most volcanically active spot on Mars will likely be mild as milk compared to places like Hawaii or Iceland. A spot rich in subterranean ice and nitrogen might be found near the equator, which is our preferred spot, as Mars is quite cold to begin with, and the equator gives you a free boost to space from its faster rotation. Otherwise, you need to go to the even more frigid polar regions to get abundant access to ice. From that ice, you can melt water, and with the application of enough energy, split that water into hydrogen and oxygen, which makes a great fuel and oxidizer for spaceships and more conventional vehicles too. Methane is even more ideal as it's a good fuel and much easier to store than molecular hydrogen is. Indeed, given that methane is just a carbon atom plus 4 hydrogen, and carbon is abundant enough on Mars, you might split water into hydrogen, then store it by mixing with carbon to make methane, or some other hydrocarbon that might take more work to make, but store easier as a liquid or solid. Fuel is probably even more critical to creating a Martian economy than food is, and both need water, so much like civilization on Earth, it's likely to be centered where the water is abundant. Siting at near nitrogen sources is also likely. And while Mars doesn't have nearly enough native nitrogen for proper terraforming, it does appear to have enough to support many settlements and cities. As an example, the Martian atmosphere is very thin compared to our own, which is mostly nitrogen, and very low in nitrogen compared to ours, at 2%. But there is still approximately 675 billion tons of nitrogen in the Martian atmosphere. Farming on Earth goes through a couple 100 million tons of ammonia fertilizer a year, not even 1,000th of what the Martian atmosphere has, and while plants use a lot more nitrogen than that, we could probably perpetually mine the Martian atmosphere for nitrogen enough to make hundreds of millions of tons of ammonia a year without depleting it, as it would presumably slowly leak back out of various domes anyway. Ammonia is mostly nitrogen by mass, one big nitrogen atom plus a trio of hydrogen, so even if we assumed we needed something like 100 tons of vegetation per person, that would still only imply 1 ton of nitrogen per person and enough to support hundreds of millions. Obviously, more can be brought in from the outer system where ammonia ice is hyperabundant, and there may be some large and more easily utilized nitrogen deposits on Mars too. Atmospheric mining is also a potentially big deal on the red planet, as while thin, the wind does circulate around at a decent rate, and is mostly carbon dioxide plus a bit of nitrogen and argon, which might make a good insulator for multi-pane dome glass. So long as you have a supply of hydrogen or ice, you can use the local atmosphere to get most of what you need for plants and people and fuel. Equatorial spots might be able to get away with solar power, but if you need to go to the caps to mine, you either need orbital space-based solar power or nuclear power plants. Uranium and thorium should be plentiful enough on Mars, and the amounts needed would also be small enough to allow economic importation even from Earth itself if need be. Mars can be solar, but in all probability would be nuclear from day one. It depends a lot on how much it would cost to build each out there, which is a little hard to properly nail down. But if it is nuclear, we probably would have an easier time mining and refining nuclear fuels for sale to the asteroid belt and the outer planets and their moons. So that might be a coin they could use to run their economy. If solar doesn't work economically for them, it probably wouldn't work for the belt or outer planets either, being further from the sun. Same for fuel production, at least for the asteroid belt, though the implication would be that you get off Mars by rocket, mass driver, or space elevator, and then ships moving from orbit to asteroid or orbit to some other moon or planet's orbit were using nuclear, probably nuclear thermal propulsion. If you get fusion working economically, which I would tend to bet you would by the end of the next century if it's even possible, then that's probably what you are powering Martian cities with. And yet if they are emerging from early existing settlements that predated fusion, their chosen locations are likely to still be based on where they could get that rocket fuel. So what does a city of 5,000 on Mars need to look like? Well, obviously you've got those power plants, and even if you do settle on the equator and choose solar, you still probably have a nuclear reactor for a city that size anyway. Something in the tens of megawatts would seem right, and we do have some good small modular nuclear reactor designs that also could be adapted to Mars fairly easily. You might have to have spinning sections to add gravity, what we call bull habitats, but my own guess is that Martian gravity will be just fine for people, plants, and animals. If not, the habitation area of your city where folks live and sleep is probably a deep bowl that spins around under a dome, and everybody exits the habitation area to the rest of the city or outside by the middle axis, bottom by tunnel or top by tower. You might have flyers stationed at such a tower, or an underground subway to a neighboring city, or to some vehicle garage full of rovers. Flight does work on Mars, both planes and helicopters, but getting enough oxygen for an air-breathing engine is tricky, so you probably go electric or carry both your fuel and oxidizer like a rocket does. You need big wings, as the gravity is lower, but the air is so thin that you must go either very fast or have very big wings to get enough lift to stay airborne. Flight is likely to be used, especially as far away as many settlements might be, and sturdy, pressurized all-terrain rovers would also be common. You probably would not have many large vehicles inside early Martian cities. You still have to move bulk freight, but it's not likely to have the economy or supply chains to be thinking about lots of personal vehicles for folks to move around they're a relatively small town with. Plus, you probably have lots of segmented domes connected by narrow and airlocked passageways. We are prone to imagining a city under a giant single dome. Indeed, such an image is what we have for the original cover art that inspired the episode, but it isn't very likely. That said, you might have a lot more underground tunnels connecting things too. You are not likely to see many roads and highways on Mars, not unless our automation is really good by then, which to be fair it probably would be. Short, packed regolith roads to local buildings outside the domes, and maybe monorails to major extraction sites or other cities or larger outposts. The dust situation on Mars tends to get exaggerated, so no, you don't need to bunker down against dust storms or constantly race around clearing dust off your domes, solar panels, or rail lines. Figure on landing pads and facilities being relatively far from the actual habitat, quite possibly a kilometer or more, and either connected by a tunnel above ground and pressurized or underground, or reached by some sort of buses and truck with airlock connections for getting people and cargo out. Long telescoping tunnels and airlocks to reach ships from some central landing bunker is an option too. Spaceships may be able to land perfectly smoothly and gracefully in the future, but at the moment, they do not. At least not reliably, and hopes to think of one as a giant flamethrower attached to a warehouse full of explosives that you're trying to softly crash onto the ground. So distant landing pads and bunkered landing facilities are very justified. You are quite likely to be building those in the bottom of a crater or bulldozing a rim wall around them too, just to serve as blast protection. You would probably do this on the moon as well. See our episode Moon Crater Cities for more discussion of that style. Hypothetically, you might build your city as a ring inside that crater rim wall, or on the outside of it. Odds are good there'd be some useful resources there, and you could sprawl your agricultural domes out from that ring. A city built around a landing site might then be literal rather than metaphorical, where we normally assume a city forming a barbell with the landing site or having on the outside edge, rather than its center. So too, the example of tall central towers of helium from Barsoom might emerge too, as we might have cities built around the base of space elevators or space towers. As to building methods, that's all about how good your automation is, which is why I tend to have an easier time believing Martian cities might be big and often with large labyrinthine chunks underground, even while early Martian settlements will probably need to be very compact and even claustrophobic. If you're looking for some good visuals of what those might look like, my friend Bryan Versteeg's Space Habs art is probably some of the most common and inspiring pieces out there, and always well researched. I'll also give a shout out to the 2023 book A City on Mars by Kelly and Zach Vinosmith, and the folks over at spacearchitect.org who have a lot of good Mars-based art, but in particular their Hive Mars Hybrid scalable settlement, and the newer Martian City, a self-sufficient excavated vertical city at the cliffs of Tempa Mensa on Mars, which has some stunning visuals and animations, but caught my eye particularly for today because while it's aimed to be a full metropolis, it's composed of individual macro buildings designed to accommodate 4,400 people, which is close enough to our 5,000 minimum city figure, I think. Those macro buildings are described as, quote, inside the rock of the cliff, each accommodating 4,440 people. These constructions, implemented after tunneling, are modular and include residential and work activities, linked together by a three-dimensional network of tunnels. The modules have a tubular shape of 10 meters in diameter and 60 meters long, with 2 floors. There are 3 different residential and 3 work modules, providing a highly flexible and scalable opportunity by recombining the modules as needed. By giving this standardization, the design ensures scalability and reduces complexity, costs, and construction schedules. All modules include green areas, urban gardens, and spaces dedicated to arts. The urban gardens are small community parks with animals and bodies of water designed to provide physical well-being. The macro buildings on the cliff are connected by high-speed elevator systems, similar to skyscrapers on Earth. This infrastructure also connects the bottom of the cliff with the top and has intermediate stops at the sky lobbies that connect the macro buildings with a separate elevating system. The highest point of the cliff is the mesa. This vast plain contains the infrastructure dedicated to manufacturing, food production, and energy generation. Crops will be grown in agricultural modules with a CO2-enriched environment, which will not be breathable for humans, and as a result, the operational tasks in these facilities will be automated. A hydroponic system increases the crop's efficiency as it requires less water and space than other methods based on above-ground crops. This sector also accommodates the production of algae, cellular meat, and bacteria for waste processing." End quote. The description continues, and again you can see the rest of it and others over at spacearchitect.org. But we inevitably come back to the same question. What is subsidizing many thousands of people living on Mars? In theory, it might be exactly that, a subsidy. A more prosperous and borderline post-scarcity civilization on Earth might be quite willing to dump billions of dollars a year into securing a foothold on Mars and pushing it till it became self-sufficient, at which time it can just keep growing as fast as inhabitants feel like having kids. If we assumed we sustained it till it got to be about 10,000 people, say in the year 2200 AD, and then that organically grew at 1% a year, then it's 27,000 people in 2300 AD, 73,000 in 2400, 200,000 by 2500, and fully 36 million by the year 3024, 1,000 years from now. That's hardly fast, but I think it represents a probable low-end conservative value of when we could say a real populated Mars as a settled planet would occur. On the flip side, if you were sending a new spaceship there every single day with a few hundred people on it for about 100,000 a year, and assuming that same 1% growth rate, that still takes you a century to get to 16 million people. And that would be on the high end of techno-optimism, I would tend to think. There tends to be a big handwave gap between a small or medium-sized base on Mars and a big planetary empire rivaling Earth that happens in a lot of science fiction. I think we might see our biggest city of Mars not even be located on Mars but in orbit around it, where ships coming and going from the surface and coming and going between orbit and other planets might dock, without having to fight that gravity well and the thin but still problematic atmosphere. Indeed, one at the terminus of a space elevator, up in high planet stationary orbit, might be a twin city with its ground station thousands of miles away, but connected by the hyper-fast bridge of a space elevator. We might call it Upper and Lower Barsoom. While the gravity well and lack of abundant volatiles doesn't make the red planet too inviting for space development, it is probably the easiest place to just conventionally settle and live on, compared to the floating cities of Venus, mirrored mushroom habitats of Mercury, or various asteroid mining bases inside cylinder habitats crammed into metal-rich rocks. So I could see it being one of the biggest jewels in the solar system civilization down the road, just not likely before we saw major development in the asteroid belt or moons of Jupiter, let alone before the moon, for the reasons we outlined in our episode Moon First vs. Mars First. Nonetheless, sooner or late, I think we do see a growing and eventually large civilization on the red planet, and eventually many people living in the cities of Mars. One alternative to heading out into space to settle other planets like Mars is to instead explore the multiverse, as theories predict there may be near infinite uninhabited versions of Earth out there, many identical to our Earth but where humans haven't evolved. But there's a lot more options on multiverses than just other timelines, and in this month's Nebula exclusive, we'll explore all the different multiverse options and the theories they arise from. That's out now on Nebula, where you can see all our episodes early and ad-free, along with exclusive and bonus content from myself and many other creators, like our monthly Nebula exclusive episodes. You can join now for about $2.50 a month, about the price of the drink or snack you've been enjoying during the episode. We also now have lifetime memberships available and gift cards that let you share Nebula with friends and family when you sign up at my link go.nebula.tv/IsaacArthur and use my code IsaacArthur. You not only get access to all the great stuff Nebula offers, like exploring the multiverse, you also be directly supporting this show. And again, for those of you who want to share everything Nebula has to offer with your family and friends, Nebula is now offering gift cards. Use the link gift.nebula.tv/IsaacArthur to give a year of Nebula to a friend for just $30. Next week, SFIA turns 10 years old on September 17th, and we'll usher in our anniversary with a look at anachronistic technologies on Sci-Fi Sunday, like folks in space with laser rifles riding alien horses around on September 15th. Then we'll look at the concept of transcendence, moving beyond the physical or to a different layer of reality and its implications for the Fermi paradox and our own future on September 19th. After that, we'll ask if privacy might be going extinct and what our options are for protecting it. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show by becoming a member here on YouTube or Patreon, or check out other ways to help at isaacarthur.net. SFIA's episodes also come out early and ad-free on our streaming service Nebula, like this month's exclusive episode, Exploring the Multiverse, at go.nebula.tv/IsaacArthur. As always, thanks for watching, and have a great week.